Hey, welcome to Printrbot Live. This is Brook from Printrbot, and I'm here to, tell you about a few things. So, this week, I like to tell you about my week, and this week I have been printing on this printer, and today I had a couple guys join me, and what we're doing is printing cell phone cases. Why? Well, because it's a challenge, I'll tell you that, and I wanted to get to know a little more details about using the Pro, the Simple Pro, on the cloud with just G-code files. So you would want to use a G-code file in the cloud, and you actually change the extension to .gco, so G-co, and that allows you to change your slice. So instead of using the forced slicing, or at least the three obvious settings, low resolution, standard resolution, high resolution, you can actually do whatever you want to with the slice. So we were using Slicer and Cura, and I designed this cell phone case after some frustrating runs with just stuff downloaded off of Thingiverse. So it's not just that I want to use some of the advanced settings in Cura. I'm trying out the new Cura. And some things that Slicer does that Cura doesn't. Like spiral vase. But also this hot end is one of our high flow hot ends. And so I wanted to use, I had to mount it. It actually is about 1/2 inch longer or 1/4 inch longer, a little bit more, 3/8. And, you have to move this. So I had to set that up, and I put a 0.75 millimeter tip on there. So that's not going to work. Usually in the cloud, it's going to assume that you have a 0.3 millimeter tip. So I'm using a big tip, a big hot end, really high flow, twice the melt zone. And I just was curious how fast we could go with semi-flex. Now I tried NinjaFlex, but NinjaFlex, I have to say, not ideal for cell phone cases. Semi-flex is about the right feel. So it snaps back, it holds its shape pretty good. It's hard to stretch and put over your phone, but not impossible. And NinjaFlex was just kind of spongy, and if any of the model was off, or it's not the printer, but if the model size was off a little bit, some of these things on Thingiverse can be of varying degrees of design quality. So anyway, since semi-flex on a 0.75 nozzle is something I can't do normally in the cloud, so I use the G-code file. So anyway, so we started printing, and the first thing I want to say is we've got these first two prints, and these two prints, I don't know if you want to zoom in on this or not. It's not a big deal, but they did finish, but it's just a bad design. I mean, I don't know how that would hold onto your phone. It's so thin. And so that was curious. But also, it's rather thick here. I was actually doing, now this is not advised, but I wanted to see the difference between a really tall layer height and, more of an average layer height. So one thing I learned, and I read this, but I just didn't heed its warning, is when you have a nozzle tip that's, let's say it's 1 millimeter, you don't want to exceed about, 2/3. Some people have different opinions, but you don't want to use a 1 millimeter layer height with a 1 millimeter nozzle, because your layer is not going to have back pressure in the filament, and it won't push out and flatten. So you end up with these round beads coming out, and it's just weird. You have to really tweak a bunch of the other settings to get it to work. So I just wanted to use as standard a settings as I could. So anyway, we were trying on 0.7, and some of our problems are probably due to too tall of a layer height. But later we just switched to about 2/3 of the tip size, which is 0.5 in this case. And man, much, much, much improved quality. But back to the files themselves. So we first printed this. This was called iPhone 7 case. I have an iPhone 7. And, the size was right, but it was just poorly designed. And one of the things that gets frustrating with larger tip nozzles, I don't know if you've ever done a print and you've got two lines laying beside each other, and there's a little gap in between them, but only in some places on the slice. So if you've got a wall that's curved to accept the exterior of the iPhone is curved when it's laid down on it, you're looking at it from the top or the bottom. And so it's kind of straight here, but then the layer thickness of the wall, or the thickness of the wall, is fat down here, and then it gets slimmer, and then it comes back up to kind of hold onto the top. Well, anyway, with those moving targets, sometimes you get line width that's too far apart. Sometimes it's really well overlapped. And so the model itself began to be frustrating for me. This one I thought was really just too thick on the bottom. I mean, it's really thick. It does have a feeling of quality, but it's just too thick on the bottom. So we stopped printing that, and we started printing another one called, these were the first two prints. I don't really see, we changed settings. Let's see. And this one, clearly we fixed something, because if you look at the sides, this is kind of wavy. And oh, I know what it was. We were doing 20% infill, and it just, the bead that it was laying down was just kind of melting all over the place, because it only would, it just did a zigzag of 20%. On this one we did solid infill, and these side, these lines, these layer lines, really straightened out because they had something to stick to consistently, not like a zigzag, so it was sticking, it's in open air, it's sticking, it's in open air. This had something to stick to the whole time. So 100% infill on these cell phone cases that are really thin walls, and you don't really need infill. You don't need light infill, you need heavy infill. So everything holds together really well. So that was a learning. Then we pulled up this second model, iPhone 7-8 or /8, and we did we did a couple more 0.7s. And it was funny because the quality we were getting on this model looked pretty good after we fixed the infill problem. And then we had all the same settings, and we moved over to this model. And while he or she nailed the layer thickness, it's just the right thickness on the bottom, so I was happy with that. Lowered the print time, because instead of 4 or 5 layers, it was only a couple. But then it got to the sides, and it was very, very curved on the sides. So when you have large layers, if you lay them right on top of each other, it's fine. But when you start shifting that over, there's a lot here on the side that can kind of droop off, and you get on curved edges, you really get varying degrees of success based on the model itself. So this was number 3, and this was number 4. I see basically no difference in these two prints. They're really, pardon me, sorry, I just hit my mic. They're identical. But you can tell that this case was designed not to print with the 0.75 nozzle, probably a 0.4. Because the features here, they're supposed to have these little buttons that get very thin-walled and like a real spongy. And I've printed this case at really high resolution, and it's uncanny. The buttons work really well, but when you go up to this thick layer height, you lose a lot of the detail. And it was designed, whether or not it was designed for a smaller nozzle or not, it was designed well enough to be a high-resolution print and work, but it just dumps out when you go to a thick a taller layer height. So the model matters is what I'm trying to get at. So I got frustrated with these varying degrees of thickness on the wall, and I designed my own. First of all, I downloaded, because I'm designing in Fusion 360, and what I wanted to do was take a model of my phone. So I downloaded a model of the iPhone 7, and I started to design on it, and then I was like, wait a second. I printed it, and it's over there on my desk. It didn't fit. The buttons were wrong. Everything was wrong on it. So I think it was one of those early models of the phone that was inaccurate before it was actually released. So I said, screw that. I'm just going to model the phone myself. So what I did was I modeled the phone, and then I made a copy of that phone because I didn't want to mess it up. And I grabbed the sides and the bottom, and I just pulled a millimeter. And so what that did was grew the phone on the sides, the curves, and the bottom, and I was left with a cell phone that was or at least a design that was 1 millimeter thicker on all sides but the top. And then I put the original phone in there and subtracted that away from the bigger one. And I'm left with this. So this, and then I actually measured it with my phone and put the buttons. You know, I had this problem with the buttons. I was worried that it wasn't going to work. So I just thought for size, I would just print it without any buttons, just a clean sides, and there's no holes in the bottom. I don't know where that other one went. But I had a blue one that I went home, and I've got these leather tools at home, and they're punches. Like if you put a new belt hole in your belt, you know, it punches a hole. And so I just went snip, 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 and put some holes in the bottom. I put some holes in the side, and I put some holes on the other side. It's really hard to do that with 1 millimeter thick semi-flex, but it kind of felt like leather, actually. But anyway, so it's a very, very good fit. Where's my phone? My case is falling apart. But you can see that it's kind of hard to get in. That's good. Kind of got to work with it to get it on there. There. But it's a very, very tight fit, and it's a good model. Now, I might grow this like 1 or 2% because it's a little bit too tight. You can feel the stretch on the filament a little bit. It might relax if I wore it for a while or left it on there for a while. But I decided that when you have a model that was designed for a really thick nozzle, you get far better results than a model that was designed for a really high resolution model. So just a reminder that when you download files and you're frustrated with your printer and it looks like crap, and you're wondering, what is wrong with this? 3D printers actually don't print anything. And here's why. Some of the models kind of suck. They're bad. Or at least they're not designed for the printer and the setup that you might have. So you're going to get varying results on that. But the real difference here was I left it very thick on, if you even feel these sides, this feels really flimsy, and this feels really solid. And this is a consistent 1 millimeter all the way around on the wall. So the intent was, I actually did some of these with a 1 millimeter nozzle. The intent was to explore if I can design a phone case that's intended to print on a 0.75 or 1 millimeter nozzle that can do spiral printing. Because on this one you'll see, well, looks like the seam, yeah. Cura does this seam. This was an older version of Cura. But, you know, it stops in the same place before it moves up on to do the next layer. And it leaves this seam down the side that looks like stitching almost, and it kind of bulges. And I forgot to move the hot end away. So there's back pressure in a nozzle when you're extruding filament. And it's even worse with NinjaFlex or SemiFlex. Because it compresses a little bit, you know, it's spongy. And so when you stop the print, it just kind of releases the back pressure and it'll extrude for a little second. But the reason I want spiral prints is A, I want to go fast, and B, I want very clean lines. I don't want to see this seam. And I figure the model is going to have to be designed for that. Anyway, so that was some fun with cell phone cases. We're still learning. I shortened this print. I think I showed it to you before, but I shortened this. It does print well on blue tape, but I think I'd like to try something else on the, you know, polycarbonate. You just can't get NinjaFlex off of, so don't do that. But maybe glue stick, or I'll put polycarbonate down with glue stick. Or I'll try one of my PEI sheets. I could put a heated bed on here, maybe that would help, but I want the bottom to be really clean too. So anyway, kind of a fun study in a very narrow use case with a challenging material. By the way, we got with, here's the settings that I ended up with. On a 0.75 nozzle, I was running at about 240 to 250, depending. We were running at 250, but I didn't really see any difference between 240 and 50. It gets a little more glossy. You can't really tell, but the higher temp you run, you end up with this glossy finish. So 250 was kind of glossy. And it did help a little bit. It seemed to extrude a little easier. We were leaving all the settings and just messing with the speed. And some of my guys hadn't printed with NinjaFlex, and so they just put like 60 millimeters a second. That's too fast. And it's especially fast when you have a .75 tip. So as you increase your tip size, you have to slow down your speed. You may still get, 20, 30, maybe even 40% speed bump because you're not doing as many lines because you've got a bigger tip and more plastic is coming out. But it's not going to go 60. So we ended up at like 35. I think we even tried 40, but 30 seemed to be very comfortable. So 30 millimeters at, I think it's a minute. No, 30 millimeters a second. That doesn't sound right. But anyway, the speed was 30. And it was .75 with a .5 layer height. And it was printing really good with this high flow. So there you go. Way more than you wanted to know about cell phone cases. So that's, I call this guy Shorty. Because again, I don't need it to be tall. And what else did we do on this? We put a bigger motor on here, which, by the way, there is room for a bigger motor if you want a little more torque. I went back to the adjustable to see if that helped. It didn't really. So I was kind of glad to find out that, no, the current design is a good design. The adjustment in that just kind of trips you up. You go too tight, too loose, too tight, too loose. The Pro comes with one that just has a spring, no adjustment screw. It's fine. That'll work fine. We'd stripped the motor screw out, so it was not aligning well. Once we got that figured out, it worked good. So that's Shorty. Now, another thing I've been trying to print is for a guy, this gentleman in Sweden. He gave me this file, and this is kind of on a theme of the file matters. So this was, he's an architect, he's at an architect's firm, and he wanted to print, little visuals to show. I don't know if this was shot with a drone or this was a Google image that he then drew over or something, but this is actual property. I don't know if it's in Sweden, but it has this topographical elevation, and he was wanting to show the client what it would, visually look like. And the first time I printed it, I had some printer problems. I forget what it was, but once I got the right nozzle on, or the right settings on my printer, this was on the Plus Pro, it printed no problem. And then it got, it was all looking so good, and then it got to this house, and I don't know if you could see this, but there's this gap right here. And I was like, oh man, the printer, in fact, I stopped the first print because it looked like it was failing there, and I just didn't know what the problem was. I thought it was mechanical. But then I went into NetFab and looked at the model, and sure enough, this area of the model was completely broken. So I don't know what he was designing with, but when you design multiple, like let's say this house was designed, then this house, then this house, this house, this house, and then he laid it onto the topographical model. He just pushed these models down into it so they were intersecting files. And the slicer, or the model wasn't solid. It had intersecting lines, intersecting triangles, and it just gave up, and whatever the default in Cura or Slicer, I forget which one I sliced it in, kind of mixed up this area, and you end up with a really bad looking print in this area. So I went in and I fixed it. It was in NetFab, and I forget exactly how I fixed it, but I just started removing triangles. Another bad area was here. Same thing, that wasn't properly made to 3D print. And so you'd think, like, he's an architect. He must know what he's doing. Well, he just has to see things visually. And so when you are looking to do a rendering of a 3D model, the rendering requirements are so different than 3D printing requirements. You really want a very, very, very clean model. Now, this was a really high-resolution model, too, and it's funny because it's just blocks. I mean, you could make this in Tinkercad. I don't mean to be condescending, but I'm saying that it's very simple, primitive shapes. And it was so high resolution, I was just like, man, why are they doing, like, it's a huge file. And it didn't need to be. But anyway, so there was mistakes made when it came, it was really my mistake. I should have checked the model first before printing, but I didn't. I made an assumption. So went back, fixed it, and now I need to print another one. And the poor guy's been waiting forever on me to ship this. But I'm just shipping it to him for free because he wanted to see how the Pro prints. Print's good. When you print a model like this and you've got white filament, beware, it is very translucent. And so you'll see, if you hold it up to the light, you can see all the infill. I think I only used about 20% infill. So I probably should have done it in a more opaque. But again, the model matters. All right, enough of that. You got any questions? What's the z-axis? On Shorty, the z-axis is only a couple inches. But it's better to travel with. So if you were throwing it in your car, it's very rigid. It doesn't have that 8 inches sticking out on top. And it's just really compact. It feels like a toolbox when you pick it up. So the z-axis is very short. I cut it down. I know it's wasteful, but I'm trying to build this printer just to print cell phone cases, so that's why. Okay, let's talk about this real quick. Oh, one more fun little thing. Thank you, Dave. They have arrived. I finally have a few. I didn't order a lot of these, but I finally have the Flux Plates, the stainless steel Flux Plates. Can you hand me that big block of magnets off my desk? Do you see them? Yeah. These are rare earth magnets. So on the Simple Pro, we use a Flux Plate. And I'll probably never get this off. And we stick the Flux Plate. We have some acrylic, and we have a few, I think 14. Let me just get one of these. I just wanted to show you that, you know, when you have aluminum or polycarbonate Flux Plate, I don't know why you'd want aluminum Flux Plate, but if you have steel, magnets stick to it, so you can hold it down. You could build something that holds this down, and then you can just pop that. Whoa! You can pop that off. This is designed for the Simple, the old school Simple, and we're going to put these in the store tomorrow. They were blue, heat-treated spring steel. I don't remember. I don't know if I have calipers. Somebody asked what the thickness was. Where's those calipers? Do you see calipers on my desk? I'll tell you what the thickness is. Now this, of course, we've added zinc plating to it. So 0.9 millimeters for you English. 365 thousandths, which in fractions, I thought that would show me fractions. I guess I'm wrong. Oh, there it is. That doesn't even sound right. 5 1/28ths. That must be the zinc coating on top. So anyway, the thickness is, it's pretty stiff. So you're not going to bend it a lot, but spring steel goes back to its form. So that's for the Simple. That is for the Play. Come here. And I got to admit, with such a small piece of spring steel, it's not going to, probably want to grab it by the corners. Then you can get some good bend out of it. But it's very stiff. And you could flip it over every time you used it. I think I had one of those clips. I mentioned last week that you can even use these little clips to put those on, or 2 weeks ago. So anyway, the Play, there's a few for the Play, a few for the Simple, and then if you have a Plus, there's one, the Plus size. You might wonder, why is there a hole in it? And that is so the zinc plater can hang that on a hook and dip it into his tank. So each one of these have one little hole. They're not intended to be indexing holes at all, like the Simple Pro has. It kind of fits over 4 screws and like finds where it needs to be and then holds down and then doesn't slip. You want to clip these down. And you know, if these get scratched, it's not a big deal. But I'll tell you, adjust your sensor before you print. Luckily, it's the opposite of, like, if you were, really what you don't want to do is adjust it for this and then remove the print plate, very dense steel, and it will have a very high offset with the sensor because it's very dense. It's an induction sensor. You take this out and try to print, and it's going to plunge into that aluminum because it's very soft, not very dense metal, and it'll scrape, and you'll hear all kinds of crazy noise, and you probably ruin your hot end. So make sure you adjust for this, and then just use this, and make sure you don't have this huge offset when you try to print on aluminum again. It'll be very different. So anyway, those will be in the store tomorrow. I have no idea on the price. No clue. I don't know. It'll be probably expensive. I don't know. I mean, I'll tell you that spring steel ain't cheap, and cutting it is very expensive, and then getting it plated is even more expensive. But I hate those polycarbonate ones, and I don't like ones that look bad. So these are be very nice. They look really, really nice. All right, let's talk about this. Oh, so my nozzle, here's a question. And yeah, by the way, I love questions. It's kind of a nice, you know, what do you call it? Intermission in between my spiels. So my nozzle homes just fine on the first 3 homing points. Then when the print starts, it is way too low. Is it the sensor? I tried adjusting the sensor height and the Cura settings. Neither are helping. So curious, he said first 3 points? He or she? So we only have a 3-point homing, so it'd be interesting to know what printer, but so let's say you had, I don't want to scratch these. Let's say you had a simple, well, let me just grab this. On the Pro, first what it does is it'll move down here, and I believe it's off to the side. It'll home Z. And basically, it's just doing that to, like, I don't want to screw anything up, so before I start probing, I want to just get my reference. Okay, I got it. That's the first kind of movement. It's not the first probing point. And then it moves out and moves down and probes here, and then it moves up and out here and probes somewhere in the middle. Boom. And then it comes up to this point and homes. And then it starts laying that purge layer. That's if you use the cloud. So we've got 3 points. And with 3 points, and really these 3 points could be anywhere, you know, it just doesn't matter. If you got a triangle, you're able to find out the plane and which way it's tilting. It's actually called tramming. And so what it wants to know, is it tilting forward, is it tilting down in this corner, whatever. Here's the thing though, like I just mentioned with the spring steel, with an induction probe, let's say if you look on the bottom of this printer, can you see this okay, Dave? Now, we've got the same thickness metal all the way here, but we got chrome steel here, and then we've got just regular metal. Now, if I have a heated bed on there, now I don't think I can even reach that far, but let's say there was a screw out here. So like on the Plus, I think, there are screws that are countersunk into the bed. That's a steel screw. So you want to be very careful that, A, you are away from the edge, because imagine if your probe was half on the bed and half off the bed. An induction sensor is going to react differently if it's off the side of the bed. It's going to think there's less metal there than there really is. It's like nothing, and then there's metal. So you want to move the bed offsets, the probing offsets, in a little bit, and you want to make sure there's nothing underneath it of dense metal. So no screws and no rail. So if you are probing on a printer like this, and you've got a steel rail right here, I would want to avoid that. Okay. V1 with the heated bed. So check, mark, put a little dot where your probing points are. And then just turn it upside down and look, is there anything underneath that? Does the heated bed, I'm trying to think how it bolts on.
Well, there's the two different styles of beds, because there's the one with the wings.
Yes.
And there's the one with the cutouts.
Okay, so check this out. An aluminum, one of our beds, I don't think, I do. Well, I don't want to get that out. That's too hard to do. But if you look on the bottom of your heated bed, there may be a cutout. It's a machined Mic 6 plate. So you want to make sure you're probing over the same thickness of metal. So if you've, on the edges, it's really thick metal, and where the heat bed is attached to it, there's 4 screws in the 4 corners. Might even be 5 on the Plus. And then you don't want to probe over those screws, and you don't want to probe over varying thicknesses of metal. So it's okay to probe over the heat bed as long as it's consistent. You probe over the heat bed each time. So try adjusting that location, and you might find that you'll get better readings. Again, you could always add one of these steel plates, and it's going to react the same with all of it because that steel is so dense. It'll mask everything underneath it. The aluminum is not going to read at all. So anyway, it could be those probe locations. Now, which printer did he have?
B1, heated bed.
Okay. Yeah, I had a guy who's very knowledgeable. He was having a problem with his probing. He said that right here it appeared to be higher, so he assumed that his bed was warped. And he says, but I put a ruler on it, and it's not warped. It looks totally flat. And a lot of people make this mistake. They assume when something doesn't work that I screwed up. And maybe I did, but the point I'm trying to make is there's a lot of variables in, a 3D printer. And one of them, and they always said this in the early days, rigidity, rigidity, rigidity. And then I made the most flimsy printer you can possibly make, right? Because if you get it pretty rigid, fairly straight, fairly flat, depending on your layer height, there's a lot of forgiving, there's ways to forgive some of those inaccuracies. But it could be that it's a perfectly flat bed that is in fact dipped, or on this printer, I dropped one off the table one time, and how are we doing on time? I dropped one off the table one time, and it was pretty all funky. I didn't know what was going on, but what I found out was the Z-axis, it landed on the Z-axis, and it was about 3 degrees off. I looked at it, I was like, oh, I think I found the problem. Another thing is these can, I don't want to hurt this printer, but if you can actually twist, you can feel a little twist in the bed. And so if you got one that wobbles, your base might actually be twisted a little bit at the front, and then it's going to be like, it'll do something weird. Also, I've got some of these, if you drop them or you hit this with a hammer, it'll actually punch through the bottom. You can't really see it, but there's a plate we press this into, this bar into on the bottom. It's just it's an aluminum brick, and it punches down a little bit too far. And so then you look at it, you step back and you look at it, and it's actually leaning forward. So that's going to, since the Y goes with the X, so you end up with this parallelogram. And if you have twist on it too, like if you loosen one of these screws and wrench it and then tighten it, you can have the two bars go twist. And when it's twisting, this bit, you can watch this real closely, and it'll kind of be going whoop, whoop, like that. So anyway, main thing is before you declare the bed a disaster and that I've screwed up and you want a replacement, it could be twist in the machine and that X, Y, Z. So how do I square it? Well, I have a block of granite that's about 6 inches thick and this big, and it is flat, super flat. So what I do is I put it on my granite block. You can put it on your granite countertop or on a concrete floor that's flat or on a really flat table. And first, check to see if it's got any wobble and check your, how straight. You can look at the top here and make sure it hasn't been dented in. That one that leaned forward, there was it caved in a little on the top of this plate. I literally took a hammer to it. I took it all apart and I took the base and I just started banging it with a mallet because I wanted to see if you could correct that. And just like you do auto body work, you can move aluminum and steel. So I got it as flat as I could. And then I made sure I bolted the bars in, and then I took a framing square. You have fancy tools to do this, but I took a framing square or just a square, and I put it against the bars, a little off to the side, and I made sure they were straight. They were pretty straight. clamped them in place, put it all back together, and it actually printed a lot better. So you can correct this stuff. By the way, another funny thing that's happened sometimes is we used to have this flaw in our shipping. I didn't ask them to support this in shipping. So here the guy is, he's traveling on a UPS truck, and this is aluminum, and there's a weak point here because I drilled a hole in it, and it's a fold. So it's kind of, it's a weak point. And so it would just do this, and eventually it would like sag down. I'm pushing it. It sag down over here. And so people were like, "You sent me a faulty part." I'm like, "Yeah, I think that was shipping." We put a block under that after we found out that happened, a foam block to support it, so they got there good. But when I get the refurbed units and I'm doing a donation or something, I'll literally just yank up on this until it's perfectly square. So that's one nice thing about metal printers is metal bends, which can be bad, but it can be good because you can fix it. If that was a 3D printed part, just pop. If that was plastic, like an injection mold, you wouldn't be able to warp it unless you got a heat gun out or something. So anyway, that's that. So my nozzle. Oh, same one. Okay. All right, let me go on to this. I've not got a lot of time. All right, so this, I'll move it over. This is what I ended up with. And this happens with me. I'll design something just for proof of concept. And laser cutting and cutting with a table saw is a lot faster than cutting on a water jet. And I always hate my first 2, 3, 4 iterations. So I've drawn this CNC. Right now I'm calling it the Adoptabot CNC because I've really decided, after making a too expensive CNC, I really decided you really got to focus in on a very, very narrow niche to hit the target. If I tried to build a cheap machine that was ultimately rigid, well, I'd miss on both. It'd either be too expensive and very rigid or cheap and not rigid at all. So I decided I don't really care about rigidity. I want it to be small because, just like I created these big CNC machines, the Printrbot and the Printrbot CNC that weighs like 100 pounds, 70 pounds. I don't use them because they're really too beefy and weighty. I need something that sits in the seat of my car. So now you can see this is just a mock-up. So no, I don't presume to make these out of wood. At least not this laser cut wood, but it's good to prototype with laser cut wood. I add a thickness of 2 of these to kind of simulate a thicker piece of wood or metal. But I like the idea that I can design a CNC that you could make with a table saw and some 3D printed parts. So that's where I'm going, but I'll tell you, I don't like where I've landed yet. The first thing I did was I actually designed it like this. I think I showed the drawing. And, oh, that already broke. Yep, it's a mock-up. Anyway, so the first one, this was the top. And I had the whole gantry moving, and I had 2 lead screws, one on each side. And I hated that because they would skew. So I wanted to definitely go to a single lead screw. So that's what I'm going to design. This is a very traditional design with CNCs. Oh, that front leg's going to pop off, too. Well, you're seeing the smoke and mirrors. But I like to see it visually in the real world to see, do I like the size of this? I have to say, I really like the size of this. It's big enough. I want to make these sides flat so that there's this not silly little notch. It just happened that the geometry of what I printed was such that I needed to put it. But this isn't going to move because I have it on that lead screw. But anyway, so it has, what's the travel here? The overall travel is about 1 foot. So I think you'd probably get 8 inches or more of cut. And side to side, you'd probably get 7 or 8. Let's see, it's going to go from here to here. So that's about 8 inches. So it was somewhere around 8 by 8. And this, again, I will not do this in the final design, but it was just a quick way for me to mock up. I don't want to use belts on the Z. But that's only about 2.5, 3 inches of travel. I'd like to see at least 3 inches of travel so you could do some carving. And this Dremel, certainly not rigid enough for me. I just have it zip tied on there because I wanted to see it. Now this, before I tore it apart and rebuilt it, inverted, I'm using parts that I have around the shop. I decided, well, we have to really purpose build this design to be 3D printed. So I'm not going to have any of these metal parts in here in the next prototype. But I tell you what, I got very interested in, I'm really excited about having a small desktop unit. I think a spindle or maybe just a router on the front here. I may or may not keep these. I don't think there's any reason not to use these use an anti-backlash nut and an Acme rod, because it's pretty nice to be that rigid and strong. So I think the Y will be Acme nut, the X, and I think probably even the Z, although the Acme nut or the Acme screws that we have are 4-start, which is a little extreme. You get more power out of a slower Acme rod. But anyway, so I'm working on this. I'm not done. I've kind of restarted twice, but I've left some really bad designs on the cutting room floor. So, but that's coming. And again, the idea is a saw table, dimensions, and maybe even a template, because I think this sidearm would fit on an 8.5 by 11 sheet of paper. You could just cut out a template and have like points where you're going to drill, and maybe even some drill guides, 3D printed drill guides. But I think we can build this thing really inexpensively with just a table saw and a 3D printer, and then some metal parts. And then I'd like to have an option. This is where I got to stay in business. Everything's open source, of course, but I'm thinking about just making the metal parts as simple and flat as I could. So if you want to add rigidity and get away from the MDF or whatever you're using, you could just bolt on metal parts. I think that would be cool, because then you can decide, do I like this or not? And if you do, you can get it much, much more rigid. The other reason I decided on this, and actually I have another drawing that has the sides are actually affixed to sidewalls. And there's just slots for these arms to reach down, and it actually moves the bed. So I haven't decided on which one, but I'm looking at both. But I like the idea of an enclosure so that you can put a shop vac on it, not get, because even when I just cut this on a table saw, man, the dust that gets all over the place is retarded. It's terrible. Anyway, so that's the, right now, the Adoptabot CNC. All right, now let's show them these. Printrbelt, 6-inch. And I think this is the first time we've showed this. The 12 by 12. Doesn't this look huge? Dave, is this going to be on your desk at home? It's big, man. It's too big. Now, I know people with, the funny thing about this printer is, if you compared this to a MakerBot, it's a little bit bigger in maybe 1 or 2 dimensions by maybe an inch or 2. But I remember the MakerBot with its plastic, cover on the top. It was really big. So I don't know. I mean, you can see that it's only half of a cube, but it's 12. You got to go 18 inches or roughly to get 12 inches tall when you're on that 35-degree angle. Well, if it was a 45, it would be 18. But it's pretty wide to get 12 inches. It's off the back here. But, I was trying to get this running for you today. The good news is we got it finished. Oh, I lost my mic. Sorry about that. Probably because I didn't clip it on. Now the audio just got a lot better. But anyway, you can see where I'm going with the Printrbelt. I went to hook it up to the cloud, and I realized that I'm missing an electronic component there to connect that. I think this is disconnected. You can see the internals here. Oh, well, I guess you can't. The tensioner, listen to that. The tensioner is 2 single screws. you adjust here and here. Is that right? Yeah, here and here. And you have to do them equally or you're going to skew your belt. So that's kind of a caveat. But right now, it's probably too tight. But you can, you're really only moving one direction. You can hear it squeak. These are 3D printed parts. They will be machined. Talked to Mark today about getting these machined. But we came up with, I think, an even better way to do these rollers. It's funny, just when you think you've got the design finished, you figure out that, no, you can do it better. Did I just bust that? No, I'm good. I heard something. Anyway, so I'm not totally sold on these, what are they, geared steppers, because there's a little bit of backlash. I'm thinking about maybe going to belts, but I don't know. But, I've stopped beating myself up over taking a long time to release this because these printers are handfuls. It's not easy because we're changing some of the rules on how these things work to do something that's, 6 foot long. It's very different. And what you think is X, Y, and Z is not X, Y, and Z. I think this printer is actually set up that this is Y, and I think this is X. Don't ask. And this is Z. So it would be more like, let's see, what would that be? It would be more like this. Would kind of help you understand. This is how it's set. Here, bolts in there. This is kind of how it's set up. And so as you look at it, this is Y, this is X. And by the way, we can change this so it's a little more straightforward. It just happens to be how the cloud was set up at the time. And then the Z, goes up and down like that. So anyway, kind of strange. But we do have the designs done. Oh, my magnets. They stick to steel. So this, I like the size of this. I like how it turned out. 4 screws on each side, and this whole top just collapses. We'll be able to ship it with a much more compact box instead of having a box that fills, half the void isn't used. Probably put right back here somewhere a stand for the filament. And then, of course, this is the same way. These actually, while I don't think this is as pretty as this, when you have such a long reach for, what is that, X or Y, you really got to support it. So these arms come completely off, and 4 screws on each side, and it breaks down almost flat pack. So that's how that will ship. And it's funny, too, because I didn't even think about it. We've got this stainless steel shim material. You can find it on McMaster Car. This shim material is 12 inches wide, and man, we did not have enough Kapton to cover it, so we've got all this Kapton. I don't know if I can move it or not. Yeah, so it moves pretty good, but it is tight. But this Kapton, we had to piece it together in a patchwork quilt, so I'm not sure exactly. I'm not even decided that Kapton is the right choice, but it is a heated bed. By the way, this was, I think, my biggest breakthrough on the design of the heated bed. The thing I'm most proud of. In fact, I'll show you. This was... So now 4 of these exist in the world. Only 4. There we go. So this was the first one, and it's funny because this is the one that's printed the most. And so when you get success like that, what does Brook do? He throws away the design and starts over. But I'll tell you why. See, I had this vertical. This is why the machine is kind of like inverted, set up backwards. Because when you look at this, it has this crossbar, and that's X. So X is this way. Now, it's kind of clever that, unlike the black belt, which you probably have seen on Kickstarter, they did it like this. Well, this was pretty cool. It worked okay. It kind of helped with gravity, instead of having to move a very heavy carriage up and down like this, it used a single carriage, just, the X carriage, and it would be able to fight against gravity no problem. And so it didn't have to lift all that weight. And then to move this across is really, really, really good motion. Why didn't I want that? Well, for a couple of reasons. One is I envision that someday, fingers crossed, I would like the idea of two of these working in unison. So almost like a continuous bed. So if you can imagine, this is one conveyor. And with an opening, I need to cut this down a little bit if I was going to do that. But now I can get something all the way through here. See? I'm getting ridiculous with my vision. Now you can get a part going through it and use multiple printers to do that. Now, I don't know if you've heard about all the hub print team. So Project Escher is dead. Everybody got laid off. But if I were to try to do this on this machine, it hits. So I would rather start, well, this might be the right choice for a single machine with a single head. I just didn't like it. I didn't like looking at this. It's hidden. The fan was in the way. You have to put the fan there because, you've got very little room down here. I didn't want a floating bed. This was so complicated underneath. It looks nice from here, but I had that too high. I made a lot of mistakes on that one. So then we moved to the next one. And this next one was, prototyping in-house. You do what you can, knowing that the guys at Microform who do our metal, they've got much better computerized controls, CNC presses. And so they can nail every angle. We're doing it by hand. And so I gave myself some extra room here. So these are ugly bins. No offense, Mark. But, and you can see this T-slot design here, which ended up being really ugly. So I didn't like either that. And I said, hey, let's design it just like Microform's going to fold it. And then, man, I got printers everywhere back here now. Whoa! Sorry. Anyway, so now we've got something that is identical to how we're going to get it made. And, I mean, I think it looks nice. Some of these we had to put some washers in. So they'll be a little bit prettier and powder-coated when we're done. But I'm liking where we're going. I've added, there's a motor here and a motor here instead of just a single motor. You get skewing. I had this complicated belt system, which I was proud of for 5 minutes and then realized it was retarded again. It was stupid, sorry. So I put two on there so they work in tandem and you don't get any binding. So that's good. Just a couple of other little details. And I hope to print on this tomorrow, but I realize there's a mechanical issue happening right there, about that short from the end stop. So anyway, there's a kind of a comical update on the Printrbelt, but at least you got to see the 12 by 12. Once that one prints, it's shipping out to Canada for a guy I promised the first one to on the big one. And when we get these in from Microform, once I fully vet this design, get a lot of prints out. The older style has a lot of prints behind it, but this one has 0. So then I will move to manufacturing, and then I'm going to ship to, give an offer to ship to the people that first signed up back in the day. It's been months and months and months now. But again, you just can't rush this stuff or you end up putting a whole bunch of money out and everybody's unhappy. I want to make sure that this is vetted, at least that it's marketed correctly, that it's not for beginners, it's not for newbies. Even for experts, you're an expert in 3D printing, but when you get a Printrbelt, you have to relearn a lot of stuff and get your head around it and understand that not every model will print because you can't lay every model down on a sideways print bed that spits out the front. But it has some advantages that are pretty intriguing. So anyway, that's an update. It's 5:32. I've gone long. This is the first time I've gone long in a while. But I did start late, so we're still under an hour. Have a great weekend. Thanks for watching. We'll see you soon, and hopefully I can come through with my promise to get this moving and printing and that moving and cutting. So anyway, have a good weekend.